put on your computer. Okay. So let's go back to sharing the screen. So today we're going to go over lab 10 and 11. So this is worth 2 labs. So it's 200 points for the whole thing. So double normal lab. Since it's 2 labs, it's actually not due until I think like the 16th of November. So it's quite a while till it's due, but I'm going to go over all parts of it now. Since I'm recording it, people can go back and watch and look at parts that they maybe had questions on later. So all the stuff that you need to do the lab is in the lab 10 and 11 folder. Quickly, before we start doing this lab, I do want to point out something because I changed the due date. So lab 12, the gas concepts lab, that is scheduled for cohort B, I believe, to be doing this week. I know you guys haven't started covering gas concepts in the lecture portion yet. So I actually changed the due date. If we go all the way down, you can see at the submit link, it's going to be due November 9th for everybody. Okay, so it was originally due for cohort B on November 2nd. I changed that to the 9th so that everybody has it due on the same day. You can see too that I kind of did it in parts. So there's a part A and a part B. So I have a video for just the pre-lab portion, a video for the data collection of part A, and then I have a copy of the data. If you click on that, it'll open an actual scanned copy of the data for part A. And then the calculations for part A. So there's quite a few videos just because I know you guys haven't covered it yet in class, so I wanted to be a little bit more thorough. But just so you know that the change of the due date for that, it's November 9th for everybody. So let me go back and start talking about lab 10 and 11. So it starts on page 59. So that's where I'm going to start. On page 59 is the pre-lab for pre-lab 10. There's actually 2 pre-labs. There's one for pre-lab 10 and there's one for pre-lab 11. And I'm going to go through both of those. So let me get my whiteboard out so you can kind of see what we're going to be doing here. All right. So with this lab, we're exploring physical changes, but also chemical changes. So physical changes are a change in like solid, liquid, gas, like a phase change. Okay, so you're not changing the chemical identity of that substance, but you might be changing the phase, for instance. So like if you have an ice cube, solid water, that would be in its solid form. When the ice cube melts, it's now a liquid form. So that's a physical change. It's still water, it's still H2O chemically. That hasn't changed. What's changed is the phase. It's no longer a solid, now it's a liquid. For a chemical change, that's an actual change in the chemical makeup. So any type of chemical reaction is a chemical change. It's where bonds are being broken and new bonds are being formed. So for the first week of this experiment, and we're kind of doing all the weeks today, I'm just going to show you short videos of each reaction for you to be able to use to write down your observations. Now the videos that I'm showing here on this video, they're all available in that lab 10 and 11 folder for you to look back at in case you don't write down an observation quick enough. So starting with part A, it says that you have a solid copper. Let me get my pen out, sorry. Multitasking here. So you have solid copper and you are reacting it with nitric acid, which is HNO3, to form copper 2 nitrate. And I believe they give all of these reaction equations to you on later pages in the lab. So copper 2 nitrate, nitrogen dioxide gas, which that's the poisonous, that's this brown gas that we're going to be seeing. You do not want to breathe that in. That's why we usually do this in the hood. And water. So it actually has 3 products. So this is going to be the first reaction that we're going to see. For part B, we're going to then take that copper nitrate that we made, so this guy here, and we're going to react it with sodium hydroxide. So the second subsequent reaction is going to be taking the copper 2 nitrate and reacting it with sodium hydroxide. And what we're going to get for products there is copper 2 hydroxide a little sloppy writing because I'm on a touch screen here. And then sodium nitrate. Now notice the equations I'm writing here, they're not balanced, okay? And in the pre-lab, it wants you to write the balanced equations. Write balanced equations for each of these processes. So yes, I'm giving you the reactants and the products, but I'm not balancing it. So you're gonna need to go back and add coefficients to balance each of these equations. They might even be given to you on later pages for you to double check your work. So this second reaction that we do with our copper 2 nitrate and sodium hydroxide, this copper 2 hydroxide, right here underlined in blue, is actually a solid. It's going to form a precipitate. So we're going to isolate that precipitate to do the next reaction, which is using that copper 2 hydroxide. And we're going to be, oops, not adding it to anything. We're actually going to be decomposing it. So this next reaction is a decomposition reaction. So for the decomposition reaction, to decompose it, we're going to apply heat. So whenever we apply heat, we use this little triangle over the arrow to indicate that we're heating it up. And when we decompose it, remember, a decomposition reaction is where we have one reactant decomposing bonds breaking to form 2 or more products. So our 2 products in this case are going to be copper 2 oxide and water. Once again, this is not balanced, so make sure you're balancing those. All right, so that is the first pre-lab, the first 3 reactions for lab 10. We then isolate in that third reaction this copper 2 oxide, which I believe, if I remember right, is a black solid, and we use it the next week for the following 2 reactions. So on page 61, it says during week 2 of the procedure, we're performing 2 more. So what I'm going to write next is part D, where we're taking that copper 2 oxide and we're reacting it with sulfuric acid. So copper 2 oxide reacting with sulfuric acid. And it tells you that it is a double displacement reaction. So that kind of helps you figure out what the products are going to be. So for double displacement reactions, if you remember, we kind of have that scheme where we have AB reacting with CD and they switch partners. So that on the product side, we have A with D and C with B. So A is copper, B is the oxygen. So when we go over to the product side, A being the copper is going to be with D, and D is SO4, that SO4 portion of the sulfuric acid. This part here. So writing that over, we have copper 2 sulfate forming. And then what's left is C, which is hydrogen, and B, which is oxygen. So hydrogen and oxygen together, they're going to make water. All right, so from there, we're then going to take that solution, that aqueous solution of copper 2 sulfate, and react it with zinc metal in a single displacement reaction. So we have copper 2 sulfate reacting with solid zinc to form. So single replacement reaction, if you remember the general scheme of those, we have the compound BC reacting with an element by itself, A, and what's happening is that element by itself is going to kick B out, being copper, so that now the element by itself is in a compound, and then B, copper, will be alone. So what that looks like over here is we're going to have zinc now with the sulfate, leaving copper by itself. All right, so make sure you're balancing those. What we're going to look at next is number 2 of the pre-lab 11 on page 61. It gives us the initial mass of copper. So what it's giving us, let me change colors here, is this initial copper that we started with at the very beginning of this series, they said is going to be 2.0465 grams. And they want to know at the very end of the experiment, notice we're ending again with just solid copper, copper by itself. So we're going to be comparing the copper we get at the very end of the experiment, that mass, to the copper that we started with. And we're going to compare it by doing a percent recovery calculation and a percent error calculation. So they give us the mass of the evaporating dish and the mass of the evaporating dish and the recovered copper. So at the very end, we're collecting this recovered copper in an evaporating dish. That's why they have the empty one massed, and then they mass it with the copper and the dish together. So to get the mass of just the copper, you want to make sure that you are subtracting the evaporating dish and the recovered copper minus the evaporating dish. So I'm going to write that calculation off to the side. You have the evaporating dish with the copper in it. You want to subtract out the evaporating dish. 0.6, what is that, 254? So whatever you get here, that's going to be the mass of your recovered copper. And I'm going to show you the equations to solve for percent recovery and percent error. So I have those on a different screen here. So let me show you those equations. There you go. So ignore that top part, that's for later. What I wanted to point out here, here are our two equations. So for percent recovery, you're going to take the mass of the copper, the original copper initially, and you're going to divide it, the mass of the recovered divided by the original mass. And then don't forget to multiply it by 100 to get it in a percent. For the percent error calculation, you're going to be using this equation here, and you're going to take the recovered amount. So whatever you get from subtracting that 40 minus that 38 amount, that's going to be your recovered. You're going to subtract the original mass of 2.0465, divide it by the original mass of 2.0465, and then multiply by 100. So once again, remembering percent recovery, that's kind of like a percent yield calculation. So the higher the percent, the better. If you got 100% recovery, that means you recovered all of the copper you initially started with. And that would be, meaning you did everything perfect. For percent error, however, we want this to be as small a number as possible, because that's how much you messed up, essentially, how much mistakes you made throughout the reaction itself. So the smaller the better for the percent error calculation. So that's kind of just a double check with your work to make sure that you're doing these calculations correctly. Also note with percent error, there's bars, around the top portion, around that subtraction. Those bars are absolute value bars. So that means it should always be a positive number. All right, let's go and look at these experiments now so that we can record our observations. So you can kind of skip over the next few pages because they're all about the procedure and you're not going to be doing the actual procedure. So I would skip all the way to page 67. And once you get to page 67, that's where this top part is going to be helpful on the screen that you see now, because this is the data collected in the experiments that we're looking at here in a moment. So go ahead and fill in the mass of the copper wire at the start, 0.3065 grams. The mass of the evaporating dish, 55.077 grams, and then the mass of the evaporating dish plus the recovered copper at 55.339. And I see I forgot to put grams in here for a G for grams. Always want to put your units. So the mass of the copper recovered, that you're going to calculate by subtracting these two numbers here to get the mass of the copper recovered. And it should be less than your original mass, which is up here. It should be less than 0.3065. And then you'll use those two values, the mass of the original copper wire and the mass recovered, to do the percent recovery calculation and the percent error calculation. So with those 3 pieces of data, you can do all the calculations on that first table. All right, the next part is all about observations. So that's what we're going to do now, is we're going to take a look at the videos, and I'll kind of explain them. I'll put them on mute and explain what you need to know about them for the lab itself. So the very first one, sorry, my office lights go off when I don't move around very often. For the very first one, let me actually go back to my whiteboard. We're looking at this top reaction here. So the copper with the nitric acid, the HNO3, and we're going to see copper 2 nitrate form, that NO2 gas, it's going to be a brown gas forming, and water. Okay, so let's take a look. So copper with nitric acid. Fast forward it a little bit because he talks a little bit about it. So that's the nitric acid. He's doing a test first that has nothing to do with the reaction. So let's look. There we go. So you can see the copper. Pause that quick. You can see the copper is copper colored, right? And then the nitric acid is actually a clear colorless liquid. So you can see the nitric acid is already in that volumetric flask. And he's going to add now the solid copper to it. So you're going to see an immediate reaction. Notice immediately the solution itself, that clear colorless nitric acid, starts turning like a greenish blue color, and you immediately see this brown gas starting to form. And you can see they have the equation written right up here. It's balanced, and it even has the states of everything. So if you want to go back and look at that. Now in our lab, we normally do this in the hood so that that brown, poisonous brown gas, that nitrogen dioxide gas, is fumigated through the hood. They're actually doing it through a bubbler to try to make it a little bit more safe. But what we would do in lab is we would gently heat our flask under the hood until there was absolutely no more brown gas coming out anymore. And then we would bring it back to our station and do the next reaction. So I'm going to fast forward a little bit so you can see once the brown gas is completely gone, that it is a brilliant blue color. If I pause it quickly there, you can see it's blue, clear solution. That's that copper 2 nitrate. That's what you're seeing now, the copper 2 nitrate. And it's aqueous because it is dissolved or soluble in the water that it's in. All right, next we're going to look at the second reaction. So we're going to take our blue copper nitrate, so this guy here, and we're going to now react it with sodium hydroxide. So these are both aqueous solutions. That copper 2 nitrate is that clear blue solution, and we're going to add some clear colorless sodium hydroxide to it. And what we're going to get out is copper 2 hydroxide with sodium nitrate. So let's look and observe how that reaction looks. Sodium hydroxide with copper nitrate. So we start with, there we go. You can see that clear blue copper nitrate, and I want you to take note that it is clear. It's not cloudy at all. You can see through it. Now when we go and add the sodium hydroxide, notice it immediately gets cloudy. Okay, so go away. So you can see it's starting to get cloudy. That's what that is. That's shows that a precipitate is forming, a solid is forming. So when we mix that copper 2 nitrate with the sodium hydroxide, that means one of our products is a solid. And you can bet that the solid is going to be the copper 2 hydroxide. And then the sodium nitrate is all going to be remain aqueous. So what we do now, and you're not going to see this in a video, is we isolate that solid, that copper hydroxide solid, and then we react that with, by heating it. We're doing the decomposition reaction next. Let me switch back so you can see what reaction I'm talking about. So now we have that solid copper hydroxide. It's sort of a whitish blue solid that we saw forming when we mixed the sodium hydroxide with the copper 2 nitrate. And now we're going to heat it up in a water bath in a test tube to decompose it to get copper 2 oxide and water. So let's look at that reaction next. So decomposition of copper 2 hydroxide. So you can see it's black already starting to form at the very beginning of this video. So that black solid that is forming from that bluish white solid, that's the copper hydroxide. The copper 2 hydroxide is the bluish white solid. As that decomposes into copper 2 oxide, which is black, you're going to see all of it turn black. Now both are solids in water, they're both insoluble in water, so they're both going to be precipitates. But the color change is what really indicates the reaction changing. That copper 2 oxide is black. And once the reaction is complete, all of the copper 2 hydroxide, the blue white solid, is gone, and all that's left is copper 2 oxide. So now we can isolate that and react it with sulfuric acid. So this is the first experiment for lab 11. Okay, so let's look quickly at that reaction. Okay, so now we're down here with this double replacement reaction where we have copper 2 oxide, that black solid that we just saw forming in the previous reaction. Now we're going to react it with sulfuric acid. Now this is diluted sulfuric acid, so it is aqueous. And we're going to see the double displacement reaction where copper is going to then pair up with sulfate on the product side of the reaction to form copper 2 sulfate, and then water being the other product. So let's look and see how that looks. So remember, we're starting now with copper 2 oxide, the black solid. And this video is a little shaky. It was kind of hard to find a good video. So Joy is just joining us. Hi, Joy. We're looking at a reaction with copper 2 oxide, and we're adding sulfuric acid to it. So it is experiment D. I'm correct. Yes. All right, so let me go ahead and play this. All right, so I said it's a little shaky, sorry about that, but that's the black copper 2 oxide solid in water. And now what they're doing is they're adding the sulfuric acid. Now this is a double displacement reaction, so it's going to take a little while for it to occur because we have that copper 2 oxide's a solid, it's not aqueous. So the reaction takes a little longer than if it was aqueous and in its ions. So we're starting to see a little bit of a color change now, and this is because that solid copper 2 oxide is reacting with the sulfuric acid to form copper 2 sulfate. And copper 2 sulfate, we've actually seen it before in lab. It is like a bright blue crystalline solid in a solid form. So we would expect the solution, once the reaction is done, to be blue, as you can see. As you can see here. So notice all of the black solid, it looked like it dissolved. It didn't dissolve, it actually reacted with the sulfuric acid. And then upon that double displacement reaction, we got the copper 2 sulfate, which is soluble in water. So that's why you don't see any more solid, because it's aqueous. And then water was the other product. So it's kind of a bluish green aqueous solution at the end there. So we have one more reaction that we're going to be looking at. And we're going to take that copper 2 sulfate. So we're looking at the very last reaction here. So here's this copper 2 sulfate, and it is aqueous because we said it was soluble in that water. It was that blue solution. And we're going to do a single displacement reaction now by adding solid zinc to it. And what we're going to see happen is that solid zinc is going to take the place of the copper ions in this copper 2 sulfate compound to form zinc sulfate. So zinc sulfate is actually going to be aqueous. So we're going to see the zinc kind of replace the copper to form this aqueous solution. And we're going to see solid copper come out, which is kind of cool. So what we're looking for here is when we start the reaction, we have solid zinc. When we end the reaction, we have solid copper. So pay attention to the appearance of the solid that's at the bottom of the flask, because it's going to change from zinc to copper. So we should see a color change from kind of a grayish black to more of a copper color, like we would expect copper to be. So let's go ahead and watch this video. So this is copper sulfate aqueous solution reacting with solid zinc. All right. So initially that solid, that blackish gray solid at the bottom, that's zinc. And then the blue aqueous solution is copper. So you can see reactions occurring. You can see that kind of by the formation of bubbles there. And it takes a while, but they're swirling the flask just to try to get the reaction to occur a little bit faster. But then towards the end, you'll notice you can start seeing already that some of the grayish black solid, pieces of it are turning a coppery color. If they let it continue and go until the reaction is complete, you'll see all of that solid is going to be a coppery color, no more of the blackish gray solid anymore. Go a few more seconds. Oops. Sorry, it kind of stopped. So I'll pause it here. So what we have now is the solid that's on the bottom is now copper in color, and then the solution itself is zinc sulfate. That's what's in solution, zinc sulfate ions. All right. So using those videos, you would answer all the questions on page 67. And if you missed any of those videos, I'm going to be posting this Zoom video that I made, but all the videos we watched are already available in the lab 10 and 11 folder, so you can rewatch them to help you write your observations. Notice on page 67 that it says give your answers in complete sentences. So make sure you can take notes off to the side, but when you write out what's happening when we added the concentrated nitric acid to the copper wire, write it in a complete sentence. You know, the solution started bubbling and a brown gas began to form, which was nitrogen dioxide gas. And just explain the whole thing. What did it look like before, during, after? So complete that for the first 3 reactions. And then number 2 wants you to describe the state and color of each of the following reagents. So when it asks about zinc, it's asking about that solid zinc that we just saw in that last video that was at the bottom of the flask, that blackish gray powdery solid. NO2, that was the first reaction, that nitrogen dioxide gas that formed. For copper 2 oxide, okay, that's the one that we decomposed during the decomposition reaction, that formed during the decomposition reaction. And then copper 2 sulfate, that's when we took the decomposed, the copper 2 oxide, and reacted it with sulfuric acid. We got out that copper 2 sulfate. So you would write your observations there. The only thing left in this lab, part 3, it wants you to write all the balanced chemical equations that were performed, including the phase label. Okay, so when it says phase label, I'll do one for you so you can kind of see what they're talking about here. So let's go back to the whiteboard, and I'm going to clear this. It's all pretty messy. And what I'm going to do is I'll do for reaction 1. So reaction 1 is where we took the solid copper wire. In the picture or the video that we saw, it wasn't a copper wire, it was copper turnings, little solid pieces of copper. So copper with nitric acid, and it formed copper 2 nitrate. Once again, sorry for the sloppy writing, it is a touch screen. Nitric gas, not really leaving a lot of room for and oops. Water. Okay, so you need to balance it. I said that before when we looked at the pre-lab, and you had to write all of these reactions balanced. So the balanced chemical equation, I just have a 4 there. I think that's it. So, oh, it's got a 2 and a 2 here as well. Okay, so there's the balanced chemical reaction. But for number 3 on page 68, you don't just write the balanced chemical reaction, it wants the phases as well. And what the phases are is it a solid? Is it aqueous? Is it liquid? So you would indicate that in parentheses after each element or compound. So copper, when they added the copper, they added it in a solid form. So you would write an S in parentheses after the copper on the reactant side. Then that nitric acid that they added, it was a clear colorless solution. And now nitric acid, yes, the acid is a liquid, but we never use it in its pure 100% liquid form. So whenever you see acids, they're always aqueous, AQ, because they're always diluted with water. So it's actually HNO3 diluted with water, so it would be AQ, aqueous. Now for the copper 2 nitrate, you could look at the reaction to figure out that there were no solids formed during the reaction. So you should know that the copper 2 nitrate is aqueous, not a solid. But you could also use your solubility tables to figure that out. When you use your solubility tables, you would find that nitrate, NO3, that ion is soluble all the time, no matter what it's attached to. So it's going to be aqueous. And I don't really have room, you would write this next to it, and I'm kind of writing it below. Now NO2, so the nitrogen dioxide, okay, that was that brown gas that was emitted when the reaction started. So we would put a G for gas by that guy. Then last but not least, we have water mixed in there as well. For the water, water's always in its pure liquid form. So we would put an L by the water. Sorry, that's kind of a weird L. All right, so you need to do that for the other, how many reactions is it? 4? Yes, the other 4 reactions for a total of 5 reactions. So you're going to write the balanced equation of each of the reactions we just watched, and they give you the balanced equations, I believe. Yeah, they give you the balanced equations on pages 63, 64, 65, so you can use those to help you with that. What they don't give you are the phases that we just covered. So you'll need to indicate, was it a solid? Was it aqueous, meaning it was dissolved in its ionic form? Ions were dissolved in solution. Was it a gas? Was it a pure liquid? And the only thing you'll probably see pure liquid is water. That's the only one that's ever going to have an L by it. Everything else will be either solid, aqueous, or a gas. So I think that takes care of everything I wanted to cover. Do you guys have any questions?
Can you go over number 2 again on page 61?
Yes, page 61. Okay. Now that I have more room, it was kind of hard for me to explain because I didn't want to erase everything I wrote since I was going to be using them for all the videos. So I'll just rewrite that. So copper. So they're saying the initial copper that you started with in the very first reaction, which we can see up here, they're saying that you had, sorry, my mouse doesn't work very well, so let me switch to my touch screen. They're saying we had 2 2.0465 grams of it. And then we did a series of all 5 of those reactions. And in that series, the very last reaction that we did a single displacement reaction with copper and zinc. So I'm just going to write that reaction quick so you can see what they're trying to get at here. So the very last reaction that we did in this series was we took copper sulfate and reacted it with zinc in a single replacement reaction so that we could get solid copper back again. And what we're comparing is the initial copper that we started with in reaction 1 to how much copper we recovered in the final reaction. So this being the final reaction here, where we get our recovered copper. So to get that recovered copper, they don't give us the mass of the recovered copper. Instead, they give us the mass of the evaporating dish that it's in, and then the evaporating dish with the copper in it. So we have an empty evaporating dish. This is my drawing of an evaporating dish with a mass of 38.6254. And then they give us the mass of the evaporating dish with the copper pieces in it. So I'm going to draw my little yellow copper pieces because I don't have a copper color. And that mass is 40.6118 grams. So if we want to figure out how many grams of recovered copper, we need to subtract these two numbers. When we subtract those two numbers, what do we get? I don't have my calculator here. Does anyone else have their calculator and want to share?
It's 1.9864.
Okay, so, thank you. So this is the grams of the recovered copper. So we have our initial copper here, and then our recovered copper here. So let me write those down off to the side, and I'm going to clear this so that you can see the next calculations. Grams, my recovered, and then 2.0465 grams is my initial. Okay, so I'm going to go ahead and clear this screen so we can just look at what the numbers are doing now. So we have percent recovery and percent error calculations. So for percent recovery, so we are going to take the mass recovered divided by our initial mass. So what this means is we're going to be taking the mass recovered is the mass that we got after subtracting the evaporating dish with the recovered copper minus the evaporating dish. So it's that 1.9864. That's our recovered mass. The initial mass, that is that mass of the copper initially that they gave us, the 2.0465. And then we multiply that by 100 to get it in a percent. Now, we should be getting a large number here. We're not going to get 100% because there's errors as you go through and we lose pieces as we go, but it should be close to 100. So probably between 70 and 90%, I would assume, when you calculate that out. That's what you should be seeing for percent recovery. The other calculation, percent error, we want to see a small percentage. So to calculate percent error, you take the recovered mass and you subtract the initial, and then you divide it by the initial mass, and then times 100. So I know it's kind of sloppily written, but hopefully you can hear my words and figure out what I'm trying to write. So the recovered is your actual, your experimental. The initial mass, that is your theoretical, how much you could have gotten if you did the experiment 100% correct without losing anything. So that's why we're subtracting by the initial and dividing by the initial, because that initial is where we usually have our theoretical in that percent error equation. Does that clear it up?
Yes, ma'am. Thank you.
Okay. Are there any other questions? I'm gonna go ahead and look at the chat really quick. So I have to do stop share to see if there's any questions in there. I don't see any questions in the chat either. So that's all I have for this lab. It's not due according to your schedule till like November 16th or something, but you have all the information you need. And I recommend just getting it in so that you can enjoy your next few weeks. So you have this lab due November 16th. You have the gas concepts lab due on November 9th. Today, I should tell you what labs you have due today, shouldn't I? I know today everybody should have turned in pre-lab 4 and lab 4 and also lab 5 and 6. So if you turned in lab 4 last week, you need to turn in lab 5 and 6 this week and vice versa. So by midnight tonight, you should have had lab 4 and lab 5 and 6 both uploaded. And I've been trying to keep on top of grading. So if you've turned any of those in, I've hopefully graded them already. So if you have both those in, you're done. If you don't, get them both in today to avoid losing any late points on that. And that's all I have for you. That went a lot quicker than I expected. So, all right, thanks for everyone who came. And let me know if you have any questions after this.
Thank you.
All right, bye guys.